In this lesson, we're going to talk about how do I add rational numbers. So the first thing you really want to understand in rational numbers is what in the world is a rational number? Well, a rational number is basically any number that you can express, whether it be a fraction, a decimal, or an integer, like negative 0.5, which is actually the exact same thing as negative 1/2. And so, like, how do I add rational numbers? So let's just start out with that right there. Let's start with 0.5 and 1/2. We can come over here and we can add them together. Let's do negative 0.5 plus 1/2. Well, we can use the number line model, but we can also use, we can't really use the integer counters because we're dealing with like a fraction here. So the number line might be the better model to use here, or we could even convert them from fractions to decimals or decimals to fractions. I'm going to convert this into a decimal, and I know that 1/2 equals 0.5, but just to show you, 2 goes into 1.0, bring up your decimal point, 2 goes into 10, 5 times 2 is 10, subtract, you have 0, so it is 0.5. So it's negative 0.5 plus 0.5, which, knowing the additive inverse, equals 0, because we basically added a number to the opposite sign version of itself. So we added negative 0.5 to 1/2, and we got 0. Okay, so that's kind of how you would add rational numbers. You got to kind of get them in similar forms if you have fractions and decimals, or if you just have like decimals, you'll work through them in a little bit different of ways. Here is an example of some rational numbers we can add. We can add 3 1/3 plus negative 6 1/6. To do this, I would first draw a number line. So now that I have this number line here, I can zoom in here and see that I have start at 3 1/3, and I want to take away 6 1/6. So I've already split this number line into 6. So I could start away. I'm going to start taking away the 1. I don't want to take away. I want to add negative 6 1/6. So I go backwards. So right here is like my third marker. So I want to go back to my third, which is really 2/6. So I'm going to go back 1. That's one whole number. I went back. And then I go back 2 whole numbers, 3 whole numbers, 4 whole numbers. I'm going right here to the 2/6, which is equal to 1/3. So I'm at 4, 5, 6. So I've gone back 6 whole numbers. And now going back to 6, and now I need to go back to negative 1/6. So I'm back here, and I'm at negative 2 and something. So I'm going to go back one more 6 to there. So I just need to figure out what this number is. So this would be negative 3, and this is negative 2. 1 6 2 6 3 6 1 6 2 6 3 6 4 6 5 6. So it's negative 2 and 5 6 is my answer. Now, if say you wanted to use this in more of like an algorithm, to like how we would add or subtract fractions, you're going to want to do it where you have to look at the whole fraction. So when you do 3 1/3, you have to look at that as the whole thing. So you want to make this into an improper fraction. And you also are going to need the common denominator of 6. So it's really going to be 3 and 2, 6. And then you do 3 times 6 is 18, plus the 2 is 20. So you'll do 26 plus negative, and then you have your 6 1/6. So it's 6 times 6 is 36, plus 1 is 37. Negative 37 6. And at this point, you're trying to figure out basically how much space is there between, if I was at 20 and I go back negative 37, where do I end up? One way to think about that is basically if you do 37 minus 20, you get 17, and you know this has the greater absolute value, so it's going to be negative 17. Or you could even use counters if you did enough of them. You could use the counters for this one as well. You could use a number line with 20 and 37, kind of ignoring the 6. And then at the end, when you get the negative 17, you put that over the 6, and you're at negative 17, 6. Now you can divide it out Knowing that your answer is negative, just divide it out doing 6 into 17. And 6 is going to go in 2. 12 minus equals 5. Don't do any more decimals. Just know this is 5, 6. 2 and 5 over 6. And you know that's a negative. So your answer is negative 2 and 5, 6. In that way in which we use improper fractions to subtract. It's another way to do it without using the number line. Fortunately and honestly, you're probably not going to see many problems that use fractions. Most of the time we deal with decimals when we are adding rational numbers that involve negatives. So when we talk about decimals for like rational numbers, let's set it like a target. Like I'm going to set this problem up a little bit differently, just to maybe make you think differently. Rather than me to straight say, okay, we're going to do 3.5 plus negative 4.23. Let's set this up and set like a target that we want to equal. So let's say we want our answer to equal negative 4.25. So we want to equal that. So how can we use one positive and one negative rational number to have a value of negative 4.25? So first we have to start out with a rational number that's like greater than 0. So let's start out with 2.5. So we're at 2.5. And now I look on a number line. So here's a quick number line I drew where I put 2.5 over here. Here's 0. And then here's negative 4.25 way over here. So we'll zoom in to kind of get to this. But we want to go 2.5. How do I get all the way to negative 4.5? Well, I'm going to have to add a negative. So we're going to add negative to go backwards. And I'm just going to kind of count by whole numbers, so count to the halfway mark. So 1, 2, 3, 4, 5, 6, and then I don't make it quite to the next halfway mark because the next halfway mark would be here, but right now I'm here. So this would be if I took a jump back if I did negative 6. If I added negative 6 to 2.5, they would get here. Now we got to zoom in to figure out what the decimal point is. So I'm at negative 6, half more, so another 0.5 would be here, and then another quarter would get me to negative 4, and then another negative quarter would get me to negative 0.25. So this is 0.5 and 0.25. So 0.5 plus 2.5 is like 50 cents plus 25 cents is going to be 75 cents. So negative 2.5, or 2.5 plus negative 6.75 should equal 4.25, or negative 4.25. Now, how do we maybe work that out with, say, actually just lining up and adding them together? Well, the way you actually do that is you're really trying to ultimately, you're going backwards in the number line, you're really subtracting. You're really not adding here, you're really trying to find the difference between these two numbers and establish if it's positive or negative. Since we know here that we need a negative answer, we know that the larger number, the 6.75, has a larger absolute value, but needs to be a negative number. But that larger number is always going to go on top, 6.75, and we're going to do minus 2.50. And when we do this, we're going to get 25 cents here, and I'm just using 25 cents because it looks kind of like money, and then 6 minus 2 is 4, and we know that because we started with a negative 6.75, and then we really are negative 4.25. So we use the difference between the two numbers and use the absolute value of the two add-ins we had up here, so the absolute value of 6.75 and the absolute value of 250. Whichever is the greater absolute value determines the sign here. So we know it's negative 4.25. So it's really not that different than integers. It's just more complicated because it's like you're dealing with decimal points and you're dealing with fractions, and you got to kind of put all those pieces together to add or subtract with rational numbers that could be negative numbers as well. So going back to the essential question, hopefully you know how to add or subtract rational numbers. or how do you add rational numbers, because we're focused on here. Hopefully you now have a better idea of how to add rational numbers.